Hey everyone, it's me, Daniel. I wanted to make this to help you guys get started with learning how to use Unity, as well as to help out with designing and making levels. So the topics I'll be going over will be the Unity editor in general, so what our different main windows will be working in are, like what's the hierarchy, this is the hierarchy, the scene view, the game view, and the inspector window. Then I also wanted to go over different asset types in Unity. So things like Gameobjects and Prefabs and sprites, that sort of thing. And then finally I wanted to bring it all together and show you how all these things are used when it comes to making and designing levels. So the first thing I want to cover involves the Unity editor in general. How can we navigate the software, and what exactly is it that we're looking at when we boot up Unity? So the first thing you might notice is that everything is split into different sections, which are officially called panels. Attached to those panels are different windows and tools, which allow us to view and manipulate information about our game. So, for example, we have this panel here with the hierarchy attached to it, this panel here with the scene, game, and asset store tabs. Don't worry about the asset store tab. And then a panel over here with an inspector tab, and a panel down here with a project and console window tab. Firstly, I'd like to point out that if you don't like the current panel layout, you are able to change it. So I can move this hierarchy tab out into its own panel and also put it back. That's not back. I can put it back onto the left. I can split panels into side-by-side panels. So I gotta have a project and console side by side, or I could split it into top and bottom. And then you don't really have to worry about getting your layout stuck this way, because you can always go back up to the top right corner and select the default layout. Here you can also save whatever layout you make and have different presets if you would like. Now, if we want to open a specific window that isn't currently already open, we can go to Window, find the section we want, and then say we want the animator, so I could just select animator and it would bring up the animator window. That being said, if you select a window from here that's already open, like the game window, then it'll just pull up the window. It won't actually bring up a new panel. If you want a duplicate window, then you need to right click on one of the tabs and add a tab. So for example, I could have two inspector windows, which could be useful if you're trying to compare two objects. So the next thing I'd like to talk about is what the main windows are and why they are useful. So first we have our scene view. And to understand this, you'll probably want to know what a scene is first though. A scene is like an independent section of our game, and each scene may contain its own assets and game objects scattered throughout. So for example, here we have a scene called Demo, and if I scroll through the scene view, you'll see that we have all these different objects laid throughout the scene. Now, by sectioning our game into different scenes like this allows us to lower the workload of the player's computer, but it also lets us focus on making individual levels and sections of our game, rather than just making everything in one scene. In addition, if we loaded everything at the same time, it would probably make the player's computer lag, and this would be completely unnecessary. But now that we know the scene displays the layout of all the different objects from within a scene, it'd be useful to know what objects exactly are in the scene. And that's the role fulfilled by the hierarchy window, which does just what I described. It displays all the it displays all the objects laid out from within the scene. So we have a thing called a camera, we have a grid, we have a player, we've got Goombas scattered around, etc. If we move on to the game window, you'll notice that it's not the same as the scene view. Like, I can see much more in the scene than I can see in the game window, and that's because the game window is a representation of what the player sees when they open the game. And the thing that the player sees when they open the game is dictated by objects called cameras, which is why in every new scene, you start with an object called a main camera. Accompanied to this object is a camera icon and borders that indicate the edges of what the player is going to be able to see. When it comes to the icons and the graphics that represent the borders, there are official names for these kind of special graphical representations of objects, and those are called gizmos in Unity. So in the top right corner of the scene view, we can disable all gizmos by clicking on this, and you'll notice the camera borders disappeared as well as the icon. But we can also select individual icons. So if I scroll down and find the camera, I can disable the icon. And I can also disable the gizmo, which in this case is the border showing you the edges of what the player can see. One last thing I'd like to mention is that we can also hide objects in the hierarchy window by clicking this eyeball icon up here. This won't actually remove the object from the scene, it's still in the game, but it simply hides it from our view. If we want to stop an object from appearing in our game, or to disable the functionality of the object, then there is a disable button, but we'll get to the inspector in a bit. So, you'll probably notice that as I'm selecting different objects, the inspector window over here on the right is changing. And the job of the inspector window is to display the properties of an object. And these properties are split up into different subsections called components. For example, if I select the main camera, you'll notice that it has a component called camera. And the camera component is essentially what makes the object a camera. If I were to disable this component, then you'll notice that it's no longer functioning. It says there's no cameras rendering. And if I remove this component, it even takes away that preview window, which is showing you another version of the game window. But essentially what I'm saying is now that I've removed that component, this object is basically not a camera. When it comes to objects within a scene, there's two main types. So we have things called game objects, and we have things called UI elements. And we'll mostly be working with game objects. So for example, in this scene, literally every object is a game object. And every game object is forced to have a specific component called a transform. This component tells us where the object is located using X, Y, and Z coordinates. And it also gives us the rotation of the object. In this case, the object isn't rotated at all. And it gives us what's called the scale of the object, which affects kind of the size of the object. So if I change the scale, you'll notice the player is expanding. when it comes to the transform, the scene view actually gives us special tools for manipulating objects. And just there you actually saw me using one of them. So we can select these tools by clicking on this toolbar in the top right, or you can also use QWERTY. So the Q key, the W key, the E key, the R key, the T key, and the Y key. The view tool lets you click on the scene view and pan the view window. Alternatively, you can also use the middle mouse button, and it seems like when you're in 2D mode you can right click as well. The usefulness of using the alternative methods is that even when I have different tools selected, I can still pan the scene view. So that was the view tool. Now the move tool allows us to change the position of objects that are in our scene. So if I select the player, you'll notice that we have a green arrow handle, a red arrow handle, and this blue square handle. Green is for the y-axis, red is for the x-axis, and this blue square handle is a plane. So if I click on the green arrow handle, I'll move the player only along the y-axis. If I select the red handle, I'll move the player only along the x-axis. And if I select the blue handle, I'll move them along the xy plane. The rotate tool lets us edit the rotation aspect of the object. So you'll notice as I'm rotating, the transform value is changing. And again, we have three colored handles. We have a blue, a red, and a green. This time, the blue handle means rotation around the z-axis. The red handle is rotation around the x-axis. And the green handle represents rotation around the y-axis. But in 2D, we'll pretty much only be rotating around the z-axis. Another thing you'll want to note is that when you're rotating, you don't want to move your mouse in a circle. It doesn't really work. You're actually supposed to move it horizontally. Except for the red handle, which you want to move up and down for. Moving on to the rect tool, moving on to the scale tool. You actually saw me just using it a little bit ago, and like I said, this lets you change the scale of the object. So if I have the player selected, I can scale the Y component of the player, the X component of the player, and I can scale uniformly by clicking that white handle. Now moving on to the rect tool, you'll notice that if I select the player, nothing really happens. And that's because the rect tool works specifically on things called sprites. Not every object has a sprite by default. You'll notice that there is an object in here with a sprite. So it has a component called a sprite renderer, and it has a goblin head sprite object. And what this tool allows me to do is to scale the transform such that it kind of manipulates this box the way I want it. The final tool is called the transform tool, and I don't really touch this one, but it's basically a combination of the move tool, the rotate tool, and the scale tool. Something you might have noticed about our player object is that it has multiple objects nested inside of it. And then even some of those objects have their own objects nested inside of them. When nesting objects, the unnested object, or what we call the root object, or what you could also call the root object, is commonly referred to as the parent. Objects nested one layer under the parent are called children, and objects nested further than one layer are called descendants. So weapon is a child of player, sprites is a child of player, but top and bottom are descendants of player. Parent-child relationships do something special when it comes to the transform component of objects. And what that is that the position of the root object, so in this case the player, the position represents its position in space. The position of the root object represents its position in space relative to what's called the origin of the scene, which is the center of the scene. More specifically, it's the location 0, 0, 0. But when we're looking at a child object, it's not showing the position relative to the center of the screen. It's showing the position relative to the position of the parent. So we have this object called weapon. And the problem with this object is there's nothing you can really use to see it. I'll select sprites instead. Or I'll select top instead. So top is the top of the player. You'll notice that its position is at 0, 0, 0. But it's not at the center of the scene. The center of the scene is, as I showed a bit earlier, somewhere it's right here. But if I select the top, it claims to be at 0, 0, 0. That's because it's located at the center of this sprite object here. So basically right here. And this sprite object, which is a child of the player, is located at 0, 1, 0. Which means that it's one unit above our location of the player. Another thing to note is that when we scale a parent object, all the children scale with it. So if I scale the player, all of these children objects are also scaling. But this does not affect the inspector value of the children at all. So if I scale the player, even though the player has now been stretched, the weapon object is still at 1, 1, 1. That's because, again, it's showing the scale relative to the parent. If we move the parent, all the children objects will also move with the parent. And if we rotate the parent, then all the children objects will rotate around the parent. And to give an example of this, if I make a sphere, or a circle, and I make it a child of the player, then if I rotate the player, you'll notice it rotates around this origin point of the player, or this pivot point of the player. But the rotation of the circle itself is unchanged because it's also relative to the player. So next I'd like to cover what the project window is, what assets are, and how we give objects like the player custom functionality. So for example, if I move the player, the things that allow the player to move involves custom functionality. But before I get onto that, every asset in our game, so here you can see assets, is represented somewhere in the project window. So assets is basically the root folder of the project window. There's also something called packages, but these contain assets as well as coding and programming libraries and that sort of thing. But assets is kind of a big term that can refer to a lot of things. So it could be a script, it could be art, it could be sound, it could be music. It basically can be a lot of different things. And to use our assets in our game, we have to put them in a scene by dragging them from our asset window. So if we look at our player, for example, we'll notice that it has a component called a sprite renderer. And the job of the sprite renderer is to display different sprites. So if we look at this top, this is a better example because it actually has a sprite attached to it. The job of the sprite renderer is to display a sprite asset within the scene, which then becomes visible within the game. But the component needs access to sprite assets in order to do this. So if I click on this, it'll open up the location in the project window where it's located. So here you can see it's under our art folder in a placeholder folder, and this is where it's getting that sprite from. When animations run, it actually loops through a bunch of different sprites. So if I were to run the game, and I think the legs are animated in this case, so I select the bottom, you'll notice that it's looping through different walk sprites. And it's getting those from here. Another thing to note is that this kind of asset here is split up into all these sprites. And the reason that is because when we get the raw asset, there are different options we can use to manipulate it, and that'll affect how these sprite assets are created. Another example of an asset is a script. So scripts allow us to manipulate the state of the game, as well as to store information about the game, and they're commonly made as custom components for manipulating objects that we attach them to. So if we look at our player object, you'll notice that we have a health script, a movement script, an attack script, and a style script. And all of these different scripts are allowing the player to do different things. So fairly obviously our movement script is allowing our player to move. It also allows our player to jump. And there's actually fields here that we can tweak to change the functionality of the script. So if I jump now, or if I lower this and I jump, you'll notice that it changed my jump height. And if I were to disable the script, then I wouldn't be able to move at all. When it comes to these custom fields that you see, programming team will be able to actually make these. So we can request different variables that we can edit. One last thing I'd like to cover before moving on to making levels are prefabs. Prefabs allow us to make pre-made, ready-to-use objects that we can drag into our scene. So for example, if I go down into a prototyping section under prefabs, we have this Goomba prefab. So I dragged it in. It already has all of these ready-to-use scripts and components. And another benefit of prefabs, other than the fact that they're ready to use, is that if I make changes to a prefab, let's say I want to make it faster, I can save this change. So you can see apply to prefab, Goomba demo. And if I do that, so first, before I save it, I'll show you an example. So I'll drag in a second prefab. On this Goomba, I've increased the move speed. On this Goomba has the default move speed of the prefab. So you notice that this one will be faster. But if I now apply the change, all other Goomba prefabs in this scene or other scenes will now have the updated move speed value, so long as none of those prefabs had their own deviant speed value. So you'll notice it also has a move speed of 10. So if I run after doing that, they'll both be at the same speed. Now, like I said, this saved value will only change prefabs that don't have or prefab instances, so this particular object in the scene, that don't have a move speed that is already different from the prefab. So to show you that visually, I'm going to change the move speed of this Goomba back to 5, so now it's going to be slower. And I'm going to change this Goomba's move speed to 7. So if I run, the one on the left will be slower than the one on the right. But if I save, if I apply this Goomba's move speed to the prefab, you'll notice that the move speed of the Goomba on the right stayed at 7. This is because it had its own custom move speed that was already different from the default. And if we want to know specifically what are all the differences between this instance of the object and the prefab, we can look at this Overrides tab. And here you'll notice there's only one difference, which if I click on it, it'll show us that the prefab has a move speed of 5, but this instance has a move speed of 7. So I could revert the change, or I could apply it, which would apply to the prefab. Additionally, if we want to quickly make changes to the prefab, and we want all of those changes to be saved to the prefab, we can select any instance of the prefab and click on this open button. So now we're viewing like the prefab version. So any changes made here will be made to the prefab. And to exit this, we just go back. Or we can click on the prefab in here and click this open button. Or we can double left click. Okay, so with all that out of the way, we can finally get to tools we'll need to make levels specifically. So here in this scene, you'll notice that we have a grid object. Under this grid object, we have these, which are all Tilemap objects. And the components that allow these objects to function as a tilemap are the tilemap component and the tilemap renderer component. You might also notice some additional components. For example, this Tilemap Collider 2D. And this specifically is what allows the player to kind of stand on the tiles without falling through them. In addition, if we look at the two-way platforms tile map, so here's a two-way platform over here, you'll notice that we have a platform effector 2D, which is what allows the player to kind of jump through the tile from below to allow the tiles to act as a two-way platform. In order to place down tiles, we have to select the tile map and we have to open a tile palette. So this brings up a window called the Tile Palette window, and tile palettes are collections of assets called tiles. Tiles themselves, if we go into our project window and go to tile assets, tiles themselves, and these are tile assets here, use sprite assets. So if I click on this, it'll bring up where that sprite is located. And then you get the sprite assets, of course, from art assets, which in this case is a PNG image. And if you want more information about how to import images and art assets, I'd recommend checking out that Intro to Unity Resources document I made, because I have some videos under the tile map section that goes over importing art assets and turning them into tiles. So with that being said, let's kind of get into how to actually draw the tiles. In our tile palette window, you'll notice that we have these different tools. The S key swaps to the selection tool. The M key swaps to the move tool. The B key swaps to the brush tool. The U key swaps to a tool that's like a box fill tool. The M key swaps to an eyedropper tool, which is officially called the marquee tool. The D key swaps to the eraser tool. I'll just call it the deletion tool so you can remember easier how to swap using the hotkeys. And the G tool swaps to a flood fill tool, which you could think of as a bucket tool. So starting with the selection tool, the S key, this tool allows us to select an individual tile or a group of tiles by clicking and dragging. And once we've made a selection, we can modify these tiles we can modify all the tiles as a group. So if I press the delete key, it'll delete the tiles from the grid. Or if I hit the backspace key, it'll do the same. The move tool, which you can swap to with the M key again, works specifically with our selection tool. So once we've made a selection, we swap to the move tool, and then we can move those selected tiles around our grid. The brush tool, which we select with the B key, allows us to paint tiles. So if I select the tile from the palette, I can then click and drag to paint where my cursor is, or I can just left click to place one. We can also paint a whole group of tiles by clicking and dragging with left click in our tile palette. And now our brush paints that pattern we just selected. The box fill tool, which we can select with the U key, is similar to the brush, but we select a group of tiles or an individual tile, and we can paint in a box. So I'm just going to select this one tile, and you can see by clicking and dragging I can make boxes of those tiles. And again, we can also do a similar thing with the brush, where we can select multiple tiles, and we can make a box that follows that pattern we just selected. The eyedropper tool, which we can quickly swap to with the I key, lets us click on a tile that's already in our grid and then use it as our brush. So one thing to note is that when you swap to the eyedropper, it'll automatically go to your brush tool once you've selected a tile. The deletion key, the deletion tool, which you can select with the D key, will delete tiles that you go over while clicking and dragging. One thing to note with this tool is that the size of the area deleted is based on your brush size. So if I make a larger brush by clicking and dragging, and then I swap to my deletion tool, I'll delete this whole area. And finally, the flood fill tool, which is the G key, will take whatever tile you have selected, and it'll flood an area. So basically, if you put your cursor on a space, it'll search the surrounding tiles for identical tiles, and it'll place the tile you want in those identical tiles. So to show an example, if I go to my brush and I make a box, there's all these empty tiles. So if I flood fill the empty tile, it'll only fill those empty tiles. Or if I go back and I flood fill the borders, it'll only fill those borders because those are the identical tiles. So those were all the different tools. Another thing you want to note is that we have multiple tile maps, so you want to be careful about which tile map you're painting on, because like I said earlier, each tile map can have different components for additional functionality, and you'll want to make sure each tile has the right functionality attached to it. So to quickly swap between the tile map that you're working on, you can use this drop-down menu here. So if I'm in tile map, it'll paint onto the tile map, this tile map, If I swap to the two-way platforms, it'll paint onto the two-way platforms tile map. And if I swap to the walkable spikes tile map, it'll paint on the walkable spikes tile map. In addition, we can also swap our palettes using this drop down. And there we can use different tiles to paint. And you'll notice that I've actually been using these tiles in the industrial proto palette for the two-way platforms. One last thing I'd like to note, and I'm not going to explain how these work here, but these tiles that have been placed down so far are special tiles called rule tiles. And these change their appearance based on the rule tiles that are next to them, or the other tiles that are next to them. So one last thing I'd like to mention about the tools for making levels is that there are some useful shortcuts that you can use with the control key. Firstly, with our brush tool selected, if we hold control and select a single tile, then it'll act like an eyedropper and swap to whatever tile we control click on. We can also control click to select a group, and now we're painting that whole box that we selected. If we're using the move tool, so M, and we control click to select, it works like the selection tool. So we can quickly make a selection and move it. Or we can do a single control click and move that. If we're using the box fill tool, then it works pretty similarly to the brush tool. So if I select a single tile, I'll box fill with it. And that was by control clicking. If I control click a kind of group selection, then it'll try and box fill following that selection pattern. When using the eyedropper, control selection more or less works the same way as it does with the brush. And it doesn't really do much with the fill tool, but we can use control as a quick way to kind of change the tile that we're filling. So if I control click on a spike, now I'm filling with spikes. Alright, so with all that being said, I think I'm going to end the video here. I would like to make another video potentially on making a demo level and kind of going through my thought process as I'm doing that, while showing off how I'm using all of these tools. So with that being said, thanks for watching.